all these sonars are constantly sending out these signals to detect if there's an enemy submarine. So from that led to research into what does environmental noise do to human beings? So this is related to that. And so it turns out really low frequency sound causes a lot of mental issues for humans. It makes people nauseous and all kinds of stuff.
Welcome to Practical AI, everybody. I'm Jeff. I'm here with Peter Lin. Practical AI is brought to you by Pocket AI.
Pocket AI is a visualization tool that allows you to prune your models without any loss in accuracy. Visualizing your model weights is like a brain surgeon being able to find individual neurons and removing them without harm to the brain. Similarly, Pocket AI allows you to analyze and prune the weights in your model. Using Pocket AI, we have proven we can select the right backbone model, get that model to actually work, make that model more stable, increase a model's accuracy, decrease the size of a model by up to 60%, and put smaller models into production for half the cost. Finally, you can be done with endless brute force training and new model trials. Pocket AI allows you to perform brain surgery on your existing models, making them not only smaller, but better.
Peter, we got a couple of topics today to hit. We're going to end with another ChatGPT story on personas. But first, let's cover a kind of a range of failures and stuff not acting properly. The first one we want to hit up was Cursor. Cursor had they were bragging about basically building out a what was it? It was a app or something,
Browser.
right? It was a what?
Browser.
Browser,
A
yeah.
browser.
So they're going to build a browser, and they say it worked really well. Well, people have since gone and looked at it, and stuff was not as it seemed. So what happened there?
Yeah, so Cursor was kind of focused on tools for programmers using LMs, and they were acquired by OpenAI. And they did this experiment where they used agents to build a browser from scratch, right? So that's the hype thing. And so they spent, apparently based on some videos, they calculated they spent about $14 million worth of compute time for the agents to build a browser. And people looked at it, and it turns out that the browser basically is marginally functional and not really a real browser. And then some open source browser developers looked at it and said, this is the most awful pile of garbage I've ever seen.
Now, building a browser is not trivial, right? I mean, it's
It's hard.
got a lot going on, right? It's
Yeah.
got JavaScript, it's got HTML stuff going on, it's got security layers and
Yeah.
all sorts of stuff. Did they, when you think of a browser, you think lightweight, this is not a big deal. And, this is stuff we practice on in coding school and stuff like that. Do you think they picked that knowing it would be a challenge, or do you think they picked it because they thought it might be easy?
I don't know, honestly. Anyone that actually has worked on writing a browser knows how hard it is. It's extremely hard.
Okay. So they probably picked it up as a challenge. And I was surprised to see that, whereas some of the Claudebot stuff that's been bragged about over the last couple of weeks, where we're talking about building apps in minutes and hours, this thing had run for several weeks and
Yeah.
still failed.
Yeah.
Okay,
Yeah.
well,
Well, I mean, yeah.
let's hop over to, we got a lot to talk about, so I don't mean to cut you off, but data centers in space. Okay, so I really wanted to get to this because this is like all the talk from like the big wig, especially Elon. He's like really into this, and you hear lots of conversation, but it's not just him, right? It's other people that are
Yeah.
saying that this is the future and we better get on board with it. The video that we'll leave in the notes here, it makes a very compelling case that this is very unlikely to be done. Tell us why.
Well, so the physics of how you cool things is really hard, right? Like when you think about a data center, a typical AI data center will consume several million gallons of water every day just to cool the hardware. And the way that, so physics, if you go back to high school physics, right? Things cool because of contact conduction or like, so some physical thing like water or air moving the energy from the hot thing to a cooler space. One space, there is no air and there's no water. So it doesn't matter if you have a water block on your GPU going to a radiator. There's nothing passing through the radiator to remove the heat. So you're just going to keep heating up the radiator. So it's not going to do anything. Yeah.
So there was the heating cooling thing. There's the energy, obviously this free energy from the sun thing that from a physics perspective seems to be a problem. And then at the very end they even get into
Yep.
like God forbid you're getting, solar flares and radiation and your entire data center gets wiped out.
Yeah.
All right. So,
Yeah. And then there's an orbit. You can't have yeah. So there's a bunch of stuff. Physics just says no.
all right. So do you think Elon's wrong, or do you think that he's ahead of the game and he's going to figure it out?
No, he's wrong. He can't bend the laws of physics. He's not God. So
All right, let's move on to the next one then, just before we hit our main topic, real quick. So, and this is the data centers making us sick. This was kind of a scary one. I got to be honest, I
yeah.
was feeling bad for people that live anywhere near a data center. Tell us a little bit about what the
Yeah.
issue is that they're running into.
So this issue actually is kind of old. I could be wrong, but I believe a lot of this started with research done by the Navy on offshore sonars and its effect on whales and stuff and sea creatures. Because for those that don't know, the U.S. has a whole chain of sonars on the coast to detect submarines, right? And they did research to figure out like, oh, what is the impact on sea life, right? Because all these sonars are they're constantly sending out these signals to detect if there's an enemy's submarine. So from that led to research into what does environmental noise do to human beings? So this is related to that. So it turns out really low frequency sound causes a lot of mental issues for humans. It makes people nauseous and all kinds of stuff. So yeah, it's been a known thing.
Yeah, so all of the symptoms that people are feeling around these things are sort of nondescript, but they're all very, very consistent with this sort of very, very low frequency sort of bombardment, like endless bombardment
Yeah.
of noise, right? And it's who knows if we're also getting radiation, a bunch of other stuff, but it's just noise, and it causes stuff at the cellular level as well, right? Which ultimately
Yeah.
impacts, your
Oh yeah,
cardiac.
like people will go outside and they'll feel nausea for no they don't know why. They're like, I can't stand up straight. I'm gonna fall over.
Yeah. And these places are so low, usually rural, that the amount of opposition you can build up in the middle
Mhm.
of rural Texas, like nobody cares. Nobody's listening.
Actually, I think in the 80s and 90s, when Reagan was into this big like military spending phase, there was military actually research into sonic weapons as a cloud suppression. So we actually have credible U.S. military built devices that actually do this kind of technology to suppress crowds
Yeah. Well,
using low frequency sound. So it's not hypothetical. We have weapons that we've built, but we said that we weren't going to use it because they're so terrible.
yeah. Well, they were talking about this in the Maduro kidnapping where something happened like this, some sort of sound or whatever. Okay. Let's
Yeah.
move on to the main topic. And this is a fun one. So we may sit on this for a little bit, but essentially explain us how these LLMs sort of create a persona through training and through the refinement process, what the
Mhm.
purpose of that persona is, and then what they're witnessing with these.
Yeah. So when you train an LLM, right, it ingests the whole entire internet and it learns different personalities, right? Because if you think about when you're watching TV or reading magazines or whatever, or comics, there are certain types of personalities and they're kind of like archetypes, right? So when we talk about movies, we think of like the hero type, the doctor, the lawyer, right? So there's certain personas that are kind of they're codified in the media that we produce and we consume. And so the models learn these things. Then in the refinement phase, in the, RLHF phase, we try to pick out the personas that we want and have those be more dominant so that it produces a good experience for the user. But the thing is all those other personas that it learned, right? The dictator, the crazy person, or someone that, you might not want, or some other persona you might not want, it's still in the model. But the problem is as you interact with the chat model, some things you say in it could cause it to drift towards the personas that you don't want.
So the net output of this then is that the user has an experience in through prompting, right, or through the window, right, of it asks a question or it gives a prompt. It gets introduced to some persona baseline. Maybe it's specific to physics or specific to history or whatever. And then as it's going
Yeah.
through, they notice that this personality type will drift into things that it shouldn't drift into, whether you want to qualify it or not as valuable or invaluable. But there are personas that are like ghost persona or witch personas or mystic personas or whatever. And all these are like in the model, but the chat itself is drifting towards one of these, and that can be bad, right? Obviously, if you have someone
Yeah.
who's suicidal, for example, and that drifts into like a serial killer persona, well, that's not
Yeah.
a good thing, right?
Yeah.
So explain to us a little bit how this drift thing happens.
So basically, so this is old paper about neural networks where the basic punchline is every weight affects every other weight in the model, right? Meaning that like everything in the model does everything. And so you can't control what it does or what it doesn't do. And what that means is as you're interacting with LLM, you don't know if something you say is going to cause it to go down one path or another path because we fundamentally don't know how it works. Like we know the frameworks that we've built, we know how to run the training, but we don't understand the weights. And so because of that, in context learning as you're prompting and you come to conversation, something you say you think is just normal could cause the model to drift in a negative direction. And so that's not desirable, obviously.
And
So
why don't they just train those personas out?
So they do in the RLHF phase, right? The human reinforced learning phase, they try to create a data set that encourages it to boost the positive personas, but all the negative personas are still there, right? Because when you're training the model, you want it to learn as many things as possible so that it learns as much as possible. Because there's some things that might be useful, but in a way that you don't know. So ideally, what you want to be able to do is after you've trained the foundational model, you can create a data set that then exposes or boosts the negative personas. You can see what weights those are, and you can then tune those weights down to suppress it even further.
Now, that is something that you would do. Are people
Yeah.
doing that right now?
No one's doing that.
Okay, so explain again how you would address this problem of drifting into a persona that we don't want.
So the way that most people use language models is they use a LoRa technique where they have a small data set, they train it for 20 to 100 epochs, and it makes it better at doing this new task, right? And so what that does is it'll boost the weights that are good for that specific task. So if you can create a data set that boosts those negative personas, you can identify exactly which weights across all the layers that are affected for that particular persona, and then you just dial those weights down.
Okay. And that's a technique you've used in other examples that seems to work pretty well. So another question then on drift, because we've talked about drift in sort of the training phase quite a bit. This is in the prompt phase, right? Or the inference side. Explain to us how they're similar and how they're different, the concepts of drift.
So the reason why drift applies to both training and inference is when you think about thinking models, it's running through the model multiple times. And so as it's doing this, it is causing it to drift because the data you're feeding it is drifting in one direction.
And when that happens when you're training, is that always bad or is that sometimes good?
It depends on the use case, but in general, if it drifts, usually what happens is the model collapses is the most obvious thing. The next thing is it just plateaus at a level that's never good enough. And then the other case is it just never gets anywhere.
Okay, good. And then do you think that these guys basically going to figure out how to keep these models within the rails that they want and not let it turn into a serial killer?
I mean, they're working hard and they're smart guys. So they're going to improve their data set for LHF. They're going to keep improving it. They're going to keep improving their prompts. But the reality is, if you can't interpret the weights of the model, how can you ensure that your prompt, right? No matter how much scaffolding you put around the prompt to tell, okay, don't do bad things, don't do like these 100 things we don't want you to do. The fact is, that's a small proportion. If you have a long conversation that's multiple days, that prompt is a small fraction of the OR data you're passing into the context window. So over time, that has less and less bearing on which way the conversation is going to drift.
Got it. Not to mention the fact that there are ways just to outright maliciously hack and get around these things anyway.
Yeah, and people are constantly breaking LLMs anyway, so you don't even need a lot of stuff. You just need the right things.
Well, the personality drift is super fascinating, and even the fact that these personalities exist, it makes sense, but it wasn't something I was aware of until I watched this, that there's the fool and the physicist and all these things, right? But anyway, cool conversation. All right. Thanks, Peter. Remember, you can follow us on Spotify as well. These episodes are there. If you have questions, obviously would love to hear them. Otherwise, we'll see you back here next time. Take care, everybody.